Hello there and welcome back to another video. A while back, I was habitually browsing eBay and came across this little computer. This is a Dell OptiPlex 7010 ultra small form factor computer, and this computer is really interesting to me because it's bigger than most mini PCs, and yet it's smaller than the small form factor computers I generally tend to end up with on here. This size even allows it to have its own internal power supply, which I think is pretty neat. In any case, the seller said that this computer doesn't respond to power at all, so let's see if we can recreate that behavior before we start doing anything to this system. After plugging in a monitor just in case it happens to post or something, I opened the side panel so that we can see if the fans move at all when it's plugged in. With power connected, there's no response to power, and even after pressing the power button, it still doesn't respond to any power, just like the seller said. With any no response to power issue, such as this one, my first suspect is going to be the power supply, especially considering the fact that pretty much all of these Dell OptiPlex computers will power on for a few seconds and spin their fans up for a moment when plugged in, and this one didn't do that. I'm quite suspicious that the power supply could be failing to output the correct voltages. Conveniently for anyone who's working on these OptiPlex systems, the power supplies Dell puts in them usually have a built-in self-test to see if they work correctly, and this unit is no different. I pressed the self-test button on the power supply, and it returned a green light, meaning that the power supply should be good. But do I fully trust that self-test here? No. So I'm actually going to test this with a power supply tester that I built because I have it. I made this power supply tester in a way that it can actually seamlessly interface with these Dell OEM power supplies, and I have a video on it if you're interested in learning a bit more about it. But what's important is that even with a load placed on the power supply's voltage rails, it passed all the voltage tests on this tester with flying colors. Well, the power supply itself is clearly fine, so at least that can be ruled out at this point. Also, while I was removing the power supply from the system so that I could connect it to my tester, I noticed that someone's done some modding to the SATA power cable in this system. The stock SATA power cable has a singular full-size SATA connector and then the mini SATA power cable for the optical drive, which for whatever reason is missing from this computer, and someone's clearly spliced in a second full-size SATA power connector, which in and of itself probably isn't the biggest deal imaginable, but it's definitely not what the DC to DC converters on the motherboard that provide the 3.3 and 5 volts for the SATA power connectors were designed to drive. Is it possible that this modified connector could have overloaded and damaged the DC converters on the motherboard in a way that's causing the system to have no response to power like it is here? Maybe. And it could also be possible that within one of the connectors on this cable there's a short, which might also cause the system to fail to power on. This is certainly a suspicious part of this computer, and I'm going to try to power on the system without it plugged into the motherboard. Though, firstly, while it's out of the case, I want to crack open this power supply because I haven't had any experience with this specific model of power supply, and I'm quite curious about the ways that different power supplies are engineered. So, for my fellow curious folk, let's take a super quick look at the internals of the unit. Quick obligatory disclaimer, don't open power supplies if you don't know exactly what you're doing, as they can be dangerous and can cause serious harm if mistreated. This unit is 200 watts, which is actually quite surprising considering the system it's in and the super small size of it. It also has no built-in fan and instead relies on the fan that's built into the front of the case to push air through it. There's nothing too crazy on the inside, just a bunch of very effectively packed components to provide that 200 watts of power in such a small package. Surely quite an interesting design though. Anyway, back to trying to power on the system without the SATA power wiring harness installed. While I'm at it, I'm also going to unplug anything else from the system board that isn't absolutely necessary for the computer to be able to turn on, so I've actually removed the front I/O connections with the exception of the power button, all the fans, internal speaker, SATA power squid, and more. Even with all of that done, however, the system still refused to power on whatsoever. There was no power light at the front of the case, and of course no fan spin because I unplugged the fans. Also, the green light on the power supply for the built-in self-test didn't illuminate when I tried turning the system on, meaning that the power supply isn't even receiving the signal to turn on. These green lights are always on when the power supplies are on these Dell computers, or at least they should be, and the fact that this one wasn't turned on here means that the power supply isn't turning on. With the power supply and peripheral internal components ruled out, it's pretty clear that there's an issue of some kind with either the motherboard, power button, CPU, or RAM. Knowing that it's an absolute lack of response to power, I actually highly doubt that it's anything to do with the power button. My reasoning for this is that, as I've mentioned before, these Dell systems power on for 3 to 5 seconds when they're plugged in to do some kind of test or something, and they'll do this regardless of what state the power button is in. And considering that we're not even getting that little power on, I think that the power button is fine and the lack of any power response is an issue stemming from another component. To further troubleshoot this, I chose to remove everything from the case and set it out on my desk desk to eliminate the rare possibility of something shorting on the case and causing this issue. With a bit of a janky setup of the motherboard, power button board, CPU, a RAM stick, and the power supply on my desk, I pressed the power button while feeling to see if the CPU got warm at all, which it didn't. Also, with these systems, due to the short length of the power cables on the power supply, it's really hard to do these desk power setups without the power supply shorting something on the motherboard. Throughout all of these tests, I was careful not to let that happen though, so don't worry about that. Knowing that the CPU isn't getting warm means that it's not getting power at all, which isn't too surprising considering that nothing else seems to get power either. Now, still not being entirely certain about what's causing this exact issue, I decided to go out on a bit of an unconventional limb and test the CMOS battery. Generally, this wouldn't have an effect on this kind of issue, but this is a 3rd generation Intel OptiPlex with a Mitsubishi CMOS battery, which means that battery is almost certainly at near 0 volts because those Mitsubishi batteries are complete garbage. I pulled the battery and gave it a test. I've also got a video on this CMOS battery tester if you like it, and sure enough, the battery measured in at 0.23 volts. Which I think is safe to consider faulty. With a fresh battery installed in the board, I tested it again and found something really surprising. I did a really horrible job of filming it when it happened, good work past me, but when I plugged the power cable into the power supply, I heard the relay in it click on, saw the green light on the unit turn on as well, and then it all turned off about 2 seconds later. That's a lot more responsive power than we've seen up until this point, and for whatever reason, a new CMOS battery caused this to happen. I tried plugging it in again, and this time it did something different. I plugged it in, and the power supply turned on, but it also didn't turn off shortly after like it had before. I left it to sit for a moment while feeling for any signs of the CPU getting power, but the entire board refused to do anything past tell the power supply to turn on. The CPU stayed stone cold, and while seeing if the power button caused any response, this was the first time that I noticed that we had a power light on the power button board. The light was solid amber, which I looked up, and to the best of what I could find, a solid amber light on this computer refers to a bad motherboard. After learning this, I was ready to take the CPU and RAM out and throw them in my testbed system, which is conveniently a 3rd generation Intel OptiPlex 7010 mini tower computer, so I could test both the Core i7-3770S CPU and 8 gigs of DDR3 RAM in it. If they both passed, I was ready to write off the motherboard as the cause of the problem and likely order a new one from there. However, when I was tearing apart the computer components that were on my desktop, I grabbed the motherboard and felt something crumble under my right hand, which startled me. I don't know why I didn't notice this before, probably because for some odd reason I didn't do an inspection of the board once it was out of its case, but what I had just touched was some absolutely disgusting corrosion on the bottom of the motherboard. That's pretty much certainly our problem there. That's some pretty bad corrosion, and combined with the bad motherboard power light code, we've got a lead. Now, I solder a bit and I make my own circuits, but I've never repaired a liquid damaged board like this. But, considering I have at least some basic soldering skills, I've got to give repairing this motherboard a shot before I give in and order a new one for $12. Because I've never repaired a liquid damaged board before, I don't really know entirely what I'm doing. But I did my best to clean off the corrosion and reflow or resolder the solder joints that were corroded. In the end, it wasn't the best repair by any stretch of the imagination, but I was pretty confident that all of the solder joints that are crucial to the board function should be functional. There was some really bad damage to some of the pins on a fan header, but I chose to worry about that after I got the board fixed, if I could. I was about ready to take the board and attempt to boot it up again, but that's when I discovered even more corrosion that I'd entirely missed originally. Based on the location of the circuit and the traces that connect it to some nearby MOSFETs and a few capacitors alongside an inductor, I'm pretty confident that this is a power supply circuit for the RAM slots on this motherboard. The corrosion present in this circuit would absolutely cause a board like this to entirely fail, and so this section clearly needed fixing as well. Again, I'm unexperienced when it comes to repairing liquid damage, and I'm an intermediate solderer at best. Though I have nearly no experience with SMD components because the circuits that I build just don't usually use them, but really all I'm trying to do here is justify the imperfect result I got from cleaning and reflowing this entire section. But at least it's better than it was with all of the corrosion on it. Even with that though, the board still wouldn't work. I went around the board for another hour or two and found a few corroded capacitors which I dealt with, but overall I couldn't get the board to work even after several different attempted fixes. Though I did manage to change the behavior of the board slightly in the process. Instead of the solid amber light, the board would spit out either a CPU or RAM error seemingly at random every time it was powered on once I was done attempting my repairs. Well, at least I tried to fix the board, and there's a chance I could if I really wanted to spend more hours working on it, but with a replacement being $12 shipped, it's just not worth it. So I ordered the new board, and once it came, it was time to get it installed. Well, actually, I didn't order the board quite yet. Firstly, I had to make sure that the CPU and RAM which came in the system hadn't been collateral damage from the failure of the motherboard. I popped both the CPU and the 2 RAM sticks into my OptiPlex 7010 testbed system, and they posted flawlessly. It was now that I went ahead and bought the new motherboard. Several days later, the new motherboard arrived, and it was time to see if my diagnosis was correct or if I've missed something somehow. With all the parts stripped out of the system, I went ahead and cleaned the case out because whatever corroded the motherboard also messed up the case a bit at the same time. With the case looking a lot better, it's time to continue my reassembly of the system, which was all going smoothly until I got to the small internal speaker. I don't recall the wires of the internal speaker being severed like this originally, so I'm pretty sure that at some point I accidentally shut them in the side panel or another piece of the computer which destroyed them like this. Even though the internal speaker isn't that important a component, I'll still quickly fix the wires with some solder and heat shrink tubing because I don't want to call this a full repair without that being fixed. And there's yet another repair that needs to be done before I can finalize the reassembly of this PC. I need to attend to this SATA power squid. I commented on it earlier, but it appears that someone soldered a second full-size SATA power connector onto the original cable so that they could power 2 drives with it. Modding systems to meet your functionality is great if you're doing it well, but disappointingly these connections were made with the twist the wires, tape it, and hope it's good method, which I don't recommend. It clearly worked in this case, but if you're going to do a mod like this, at least make sure you know what you're doing and are okay with the risks of doing something like this, and use either a crimp or solder, or at least wire nuts or Wago terminals on the wires, please. Anyway, I'm going to remove the second SATA power connector from the squid and do my best to return it to its original state. After removing the extra SATA power connector, I noticed that this was done by using a knife or something to shave the insulation off of the original wires, and then the other connector was just tethered onto that exposed bit of conductor. I honestly expected the original wires to be entirely severed, but they weren't. In any case, I can't just leave those parts exposed, and the conductors there don't seem to be in the greatest shape, so I'll be cutting the wires, stripping a little more insulation off of them, and performing a full solder and heat shrink tubing splice. In the end, the repaired cable looks pretty good I think, and is more than good enough to supply power to the SATA drives one could connect to it. After continuing to reassemble the system while adding a 256GB SATA SSD for a boot drive on the way, it's finally time to test the whole thing. I'm very confident that the new motherboard will be the solution, but let's give it a proper test before I wrap this video up. I powered on the system and was greeted with a "no boot device found" message on my monitor, meaning that I'm pretty certain this system should be good to take a fresh Windows install and hopefully be used as someone's computer for a couple more years. In any case, that's all I have for you today. Hopefully you were able to at least enjoy this video and maybe even learn a thing or two. I hope to see you next time. Goodbye.